just an overview of chemical engineering as a discipline. And then we'll go into the Ask Me Anything session. Not just myself, but my colleagues are here, and we can answer pretty much any question from any direction that you would have thrown at us. Yeah. So I think without further ado, what I'll do is I'll simply share my screen, share my PowerPoint, and let's just get into it. So hopefully you can see my screen. Yeah. All right. So let's talk a little bit about chemical engineering, right? Chemical engineering essentially is the profession that deals with chemical and physical transformation of materials that we get from nature. Just a handful of materials that we get from nature. Chemical engineers use their understanding and their knowledge to build processes that transform this handful of materials that you see on the bottom of this slide into thousands of value-added products that end up becoming the things that we use in our daily lives. So if you take actually a look at this slide, nearly everything that we use in our daily lives, medicines, consumer products, semiconductor chips, foods, flavors, fragrances, fabrics, fuels, nearly everything that we use inevitably involves molecules or products that have undergone a chemical engineering process. So it really is a central discipline in maintaining the way we live in our highly industrialized civilization, right? Now, besides meeting the needs of growing societies, chemical engineers are increasingly playing a very prominent role in tackling global challenges that face us. We are living in a very interconnected world, right? Which means any crisis, any problem that hits some part of the world hits the whole world, right? So we share many crises together, and chemical engineers are playing important roles in really thinking through solutions about challenges related to climate, energy, water, and healthcare. So what I'll do in the next 5 minutes is really just quickly highlight some of the things that chemical engineers are contributing to, and I hope we can have a bigger discussion about that in the session that follows. Now let's start with climate, right? Now, one of the biggest challenges facing us in the zone of climate is really mitigating the amount of carbon dioxide that reaches the atmosphere, right? So if you look around us, nearly every major global scale solution that has been proposed and that is considered viable for the capture of carbon from the atmosphere, nearly every one of them is a chemical engineering process. Whether you're dealing with direct air capture of carbon dioxide, or capture using membranes or specialized adsorbents or reactive chemical looping technologies, every single one of those solutions is a chemical engineering solution. And in fact, we chemical engineers are actually very used to providing solutions that meet the needs of society and meet global challenges at scale. The simplest example of that is one of the greatest innovations of the 20th century, and that is the Haber-Bosch process that was used to fix nitrogen from the air and make it into ammonia, which ultimately becomes fertilizers, which enabled us to provide food for billions of people across the globe. So indeed, challenges that are global in scale come under the remit of chemical engineering. Now, we all talk about energy, right? Green energy is one of the biggest challenges facing us today. The march towards greener, more sustainable sources of energy. Who's leading the way towards that energy transition? It is still chemical engineers. So for example, chemical engineers, including colleagues at NUS Chemical Engineering, are playing a big role in really moving towards greener sources of energy. In fact, Singapore is now home to one of the world's largest biorefineries, which uses waste molecules, for example, from food sources, and turns them into extremely valuable fuels like jet fuels, which airlines like Singapore Airlines are using. So it's really fascinating how we are facilitating this march towards greener sources of energy, and chemical engineers will continue to play the pivotal role in this transition. Now, chemical engineers have also, for decades, been building systems and solutions that address our needs for water. Now, the availability of clean water is a big challenge across the globe, which is surprising because we're surrounded by water, right? But 97.5% of the water that surrounds us in the oceans is undrinkable. Why? Because nature has mixed salt into it. Now, the unmixing of salt from water is a molecular separation problem, bang in the center of the field of chemical engineering. Chemical engineers design desalination processes that allow you to unmix what nature mixes. And in fact, colleagues at NUS Chemical Engineering are playing a very important role, not just in providing clean drinking water, but also in working with public agencies like the PUB in Singapore, in thinking about processes that help clean up municipal wastewater, and so on and so forth. So the video that is playing on this slide is actually a technology developed at NUS. It's a pilot facility to treat 10,000 liters per day of municipal wastewater, which has been commissioned by the Public Utilities Board. And this is the work of one of our professors, Professor Jiang Sui. She's amazing. She works in this area. And it just goes to show how much we can contribute to such areas. And lastly, right, we've all been through a 3+ year pandemic. Now, let's take a look around in this meeting, right? Either you've taken the Pfizer vaccine or the Moderna vaccine, or if you're like me, you've taken both, right? Now, let me just spark a little in your head. One of the co-founders of Moderna is a chemical engineer. That's Professor Robert Langer, one of the most famous chemical engineers in the world. Now, you would say, what has chemical engineering got to do with the COVID vaccine? It's RNA, right? Well, starting from the discovery of that RNA that treats the virus, right? How do you package that RNA into a form that is stable? You're able to create it stable, ship it to millions of people around the world, and be confident that once it's administered, it will be effective. All the operations that you need to go from discovery to actual vaccine are essentially chemical engineering vaccines. So chemical engineers have a big role to play in healthcare. Modern RNA therapeutics combine biology, RNA biology, with chemical engineering. And that's something that cannot be emphasized enough. So we play a role in solving global challenges which range in scope from climate to energy to water to healthcare. So that brings us to the question of what we will learn in chemical engineering, right? We learn only one what question in chemical engineering. What indeed are the key physical, chemical, mathematical, and engineering principles that enable you to design? The word design is super important. Design clean, energy efficient, sustainable, and economical processes. Processes is an important word for chemical or biological transformation of naturally occurring raw materials. Just this one what question, right? But once you go through a course in chemical engineering in a department like mine, what that enables you to do, almost like a superpower, is enables you to answer many how questions. Some of those how questions are listed on this slide. How do you capture carbon dioxide to minimize environmental damage? How do you provide cheap, plentiful drinkable water? How do you create new vaccines in short turnaround times? How do you create better, faster, and smaller computer chips? Semiconductor manufacturing is essentially chemical engineering, right? And even more science fiction scenarios. The absolute core questions that you need to answer the question, can you make living on Mars a feasible proposition, involve chemical engineering operations that combine simple molecules to make more complicated molecules that sustain life. So fascinating. Now, in NUS Chemical Engineering, right from year one, we immerse you in the foundational concepts. So for example, in year one, we have a studio-based course that introduces to an intellectual map of the key landmark concepts of chemical engineering, everything from systems, conservation laws, models, and rates, to molecules in motion, phenomena like osmosis and diffusion, to energy in motion, the transfer of heat, and in the end, designing reactors to engineer chemistry. So this is something we do very vividly in a studio-based environment, and you do experiments that are not just doing experiments for the sake of doing that, but to visualize concepts, to better understand new and interesting ideas that you will then deploy as chemical engineers in solving important problems. This is just a fascinating example of semester 2 in chemical engineering at NUS, where you actually work with biological cells as chemical and pharmaceutical factories. You will actually do biotechnology and build bioreactors to convert, for example, fruit-based raw materials into molecules that are valuable both as foods, but also as vaccines and in other application scopes. So it's very fascinating, hands-on, and we make sure that theoretical understanding is coupled to practical implementation. Now, in terms of careers, as you can imagine, right, we have 5 decades of students who've gone on to nearly every industry sector that you can think of, right from, of course, the chemical sector to the pharmaceutical sector to the energy sector, but also in sectors such as food and consumer goods, environmental health and safety. Semiconductors is a big sector that our students go into. And then, of course, with your training in engineering, you're also able to enter other sectors like finance and management. So it's a very flexible discipline which enables you to enter any career of your choice. Now, and we can discuss this in the discussion session later, but it's really very exciting in terms of how your curriculum is structured, right? You have this unique ability to actually build your own degree based on whatever notion you may have in your mind about a career that you want. So, for example, this is just indicative on this slide, but if you wanted a career in the pharmaceutical industry, you could take our chemical engineering core curriculum and the College of Design and Engineering common curriculum. And on top of that, you could stack up specializations as well as minors, right? And so a minor in pharmaceutical science, a pharmaceutical engineering specialization, and you're good to go. But you can do that for a number of different careers. Actually, the number of combinations is really quite fascinating and diverse. And it's really something that we worked hard to make sure that you have that flexibility, and that if you're clear about what career you want to pursue, you can actually build your degree towards that career. Now, we're really very proud of our alumni. As I said, we have 5 decades worth of alumni who really entered into nearly every sector. We have produced engineering leaders, leaders who have gone on to lead in the petrochemical industry on the one hand, in the pharmaceutical industry on the other, and some who have also become ministers of state, right? So it's chemical engineering really allows you to go anywhere from energy to healthcare to government and everything in between. I just wanted to show you this, right, to emphasize that academic family. We have an academic family that spans 5+ decades, and we meet very regularly. We have very, very tight connections. In our alumni gatherings, it's not unusual for somebody graduating in 2024 to meet somebody who graduated in the 1980s and to make that instant connection that you're NUS Chemical Engineering, I'm NUS Chemical Engineering, and that you have this network of possible mentors that you can actually lean on. And we all are very, very key in actually making that network and making that family as vibrant as possible. So when you join us, you're automatically inducted into this giant family. And it's one of the most rewarding things that, for me, having spent 18 years in NUS, it's been one of the most rewarding things to see this network grow. And finally, I'd just like to end by saying that by welcoming you to NUS Chemical Engineering, we are actually very proud of our disciplinary strength, both in core areas as well as frontier areas. We are very passionate in engaging teachers, and we constantly think about how we can possibly make our teaching methods better to more appropriately and more vividly convey the ideas to new generations of students. We are very proud of our strong industry connections. Nearly every one of us has, in terms of, for example, in our research, we have very strong connections to a diversity of industry sectors. We have a wide alumni network. And of course, the discipline offers you fascinating and diverse employment opportunities. So I'd just like to thank you very much. And I think let's just have a discussion. So thank you very much for sharing your time on Friday evening. And I think, Coco, we can just move on to the discussion session.